Hello and welcome to this presentation on LUSAS version 19. More design, more applications, more productivity. I'm Julian Moses and I'll be looking after this presentation today. Now, if you have any questions as we go through the presentation, please use the GoToWebinar chat box to type in any questions. I will try and answer those questions through the sessions, or if not, later via email. Now, this session is being recorded and will be made available after the event to the people that have registered. Now, in version 19 of LUSAS, there are many new developments. In this particular presentation, I'm just going to concentrate on 3 of them. The Composite Bridge Wizard for modeling 3-dimensional structures quickly and efficiently. The new grillage sections and temperature profiles, and reinforced concrete design to AS 5100. So let's start with the composite deck analysis. The new Bridge Wizard is a way of rapidly building models efficiently. It's going to construct a 3-dimensional model, and these models can be straight or curved alignments. We can also now look at influences across a built-up section. So in the past, we had to look at, say, an influence of the bottom flange tension, but now we can look at an influence across the composite section. So an influence based on the deck slab, the flanges, and the web. We can also look at something called branched analysis. So through a stage construction process, you can take a branch off that stage construction and look at, say, construction loads, or do an eigenvalue analysis. And I'll be showing you more of that in an example later. Now, the Composite Wizard is a series of utilities that you use to define the data for the bridge structure you're looking at. Now, rather than talk about the dialogues here, I'm actually going to show you inside LUSAS in a minute. Once you've built your 3-dimensional structure, you can obviously look at the different phases of construction. So here we've got a model where we're looking at the bare steel. So the slab hasn't been activated yet. And I can obviously look at the stresses in the webs or the flanges. But using our slice utility, we can cut through the flanges and webs and come up with a bending moment on the combined section. We can also do that on the superimposed composite section. So this is where we've got the slab activated. I can look at the stresses in the deck, but I can also slice through the structure and look at the composite bending moment diagram. Now, as I said earlier, we can also now look at influences of a slice. So for using the vehicle load optimizer, I can actually look at the, say, the bending moment on the composite section for the influence. Now, what I'm going to do is use this simple 2-span bridge example to show you the Bridge Wizard. Now, this is an example that's published by SCI, and it's a simple 2-span bridge, 4 girders with various bracing alignments. So let me have a look at this in LUSAS. Okay, so what we're looking at here is essentially a blank LUSAS model, but you'll notice in the Utilities tab here, I've got a number of items set up. Now, these are the utilities that we use for the Bridge Wizard. Now, if I look at the first one here, double click on it, what we're looking at here is the data defining a section within the girder. So at the top here, we're defining the slab. Now, we're working in millimeters in this model, so we've got a 3.7 meter width of slab. The slab's 250 mil thick, and we've got a haunch representing this gap here in the model. And that's made of a concrete material property here. Now this example is using EU properties. We've then got a definition of the flange here. So 500mm width flange, 40mm thickness, a definition of the web, and then the bottom flange. Now, in this particular model, you define as many sections as you require along the lengths of your girders. So here you can see we've got the same section, but a slightly different web thickness, and then we've got a pier section here. So you start by defining the girder sections. You then, under the girder tab here, define how these are aligned along the length of a girder. So here, this is the positions along the length of the girder. So for the first 3.5 meters, we're using girder section with the 12mm web, and then we change to the girder span with the 10mm web, and then further along the structure, we change to the pier section. Now the change can be a step where you look at just an increase of the section at a particular distance, or it can be a linear interpolation where you have a smooth transition over a length. So here, over this length of 300 millimeters, we've got a variation, a transfer across there. We can also set up where we want intermediate web stiffeners along the length of that girder. If I now look at the span definition here, this is how many girders we want along a particular span. Now in this particular case, we've got 4 girders, but you'll note here that we've got mirroring on the 2nd and 4th girders about the web. And that's because when we set up the intermediate stiffeners, we had those on one side of the web. By mirroring them here, we actually have them on the other side of the web. So essentially what we're doing is creating 2 braced pairs of girders in this particular example. We're also setting up down here how we want bracing to be constructed between the girders. So here we've got bracing between girders 1 and 2. We've got no bracing between 2 and 3, but we've got bracing between 3 and 4. So 2 braced pairs of girders. I can also set up how I want the support conditions to be set up at the different positions, and also how I want support bracing to be considered. Down here, I'm setting up the characteristics of the stiffeners and the bracing. So if I just look at some of these, here we've got a bracing, a stiffener that's 200mm width, it's 20mm thick, and it's on the right side of the web. And that's a web stiffener left, effectively. Down here, we've got the bracing definition. So what we've got here is a cross bracing with no top chord. So here you can see that we're going from the top of the web on the left girder to the bottom of the web on the right girder. This is the opposite, bottom of the web on the left girder, top of the web on the right girder. And then we've got a bottom member here going from the bottom of the left girder to bottom of the right. So essentially all of these utilities are just defining data that the wizard is going to use. Now if I go to the bridge menu, still Composite Bridge Wizard, you'll see that the items in the utility tree view reflect the items here. So essentially it's the process of working your way down through this menu structure to define the various data inputs. And once you've defined all the various data inputs, you can generate the bridge. So if I click on Generate Bridge now, this is what I've called this particular example. So P357, if I hit Generate, it'll take a few seconds to generate. Along the bottom of the LUSAS window, you should see a green taskbar, and that's just showing you the progress in constructing the bridge model that we're working with today. Once it's worked its way through that process, you'll see the 3-dimensional model of the bridge appear on the screen. So here we've got the model on the screen, and if I then look underneath this, you can see it's fully defined, the bridge structure, including the stiffeners and the bracing. If I rotate this model around, you can see that we've got these two braced pairs where the intermediate stiffeners are just on the inside of the girders rather than on the outside of the girders. So that's the basic concept of the Bridge Wizard. It allows you to efficiently and rapidly build models that you can then start to work with. Now I'm just going to jump to a slightly different model I've got in the background here. Okay, so this is the model that I want to talk about, the branched analysis. Now, basically what we've got here is a curved bridge rather than a straight bridge that we've just looked at. And we've deactivated the slab because what we're going to look at is a pouring sequence of the slab itself. So here, we've got the construction sequence of the slab, and if I set active pour 2 here, you'll see that the pour 1 is now activated, and if I set active pour 3 here, you'll see that we've now got pour 2 activated. So essentially we've got a stage construction process, but the reason I'm showing you this is to show you branched analysis. So if we look at slab pour 1 here, normally you would just have a sequence of construction stages, but here we've got a branch. Now in this case, this is a linear branch where we're looking at additional construction loads that are placed onto the structure while we pour the wet concrete of slab 1. So if I just set this active and switch on the loading, so this is the additional construction load that will be applied only to pour 1 here while we cast the wet concrete. If I look at the next one here under pour 2, again, these additional construction loads can be taken into account at any particular point in the construction process. Now, in a typical stage construction, the loads are passed through and remembered as part of that construction loading. But on a branch, they're not remembered. Essentially, you can take a branch and use additional loading. You can do an eigenvalue analysis. You could also do something like a linear or non-linear buckling analysis, but it won't affect the main trunk of the analysis. So it allows me to look at additional effects without having to create additional models. So that's the branched analysis. Now, if I go back to the PowerPoint here, I now want to talk about the additional or the new grillage sections that are being implemented into LUSAS and how they can help you. Now, these grillage sections can be a steel plate girder, they can be precast, they can be rectangular, a diaphragm section, or they can be an arbitrary section. And on top of these sections, we can apply a slab. Now, these slabs can have a width. That width can vary. We can look at the effective width on the slabs as well. And we can also set up rebar for how we want to deal with the slab if it's cracked in tension. Now, if I look at the girder and slab tab in the dialog, this is where you choose whether you want the sections to be uncracked, you want gross sections, or you want cracked in tension. We can specify how we want the torsional constant to behave, and also how we want to set a warping restraint if you want to use a warping restraint. We've also got grillage slab sections, and they can be for just a solid slab. Again, these can be cracked in flexure, or we've got the same for a voided slab, both longitudinally and transverse. Now, to use these grillage sections, we also need to define a grillage material property. And this grillage material property allows you to set the materials for the slab and the girder. So what we could have here is for short-term material properties, long-term material properties, and wet material properties. Now, the difference between the long-term and the wet material properties is how we treat the stiffness here. So if you're just looking at long term, where you're applying, say, superimposed dead load, say surfacing, you would want both the stiffness of the slab and the stiffness of the girder to be taken into account. But for the wet concrete case, you only want the stiffness of the girder to be taken into account, but you want the mass of the slab to be applied to the girder section on its own. Now, this is automatically done for you, so you don't need to use activation or deactivation to discount the slab. You can use these in terms of a multiple analysis. And in terms of a multiple analysis, again, you're setting up the different criteria for the analysis. So you can have short-term. Those short-term material properties are based on the basic elastic modulus of the materials. Long-term, you might take the basic elastic modulus and divide by 3. And this is to take into account the creep effects. And you can have the wet concrete case. And the wet concrete case is where the slab stiffness is essentially switched off. So the wet concrete mass will be applied to the girder only. Now, as well as the girder sections, we've also introduced nonlinear temperature profiles to AS5100. And these allow you to set the nonlinear temperature profiles for the location of your structure, and it will then apply the positive and negative effects as you want from the design codes. Now, if one of your design codes isn't available to you, we've also got the generic facility where you can set up your own nonlinear temperature profiles, and you can then view those temperature profiles on the visualization that I'm showing you here. So yes, we've supplied some design codes, but you can also use the generic facility for looking at any design code. Now, what I want to do is just have a look at these girder sections and the temperature profiles. So if I go back to the modeler, I'm just going to open up a pre-prepared model that I've got here. Now, once this is loaded, it's essentially just a simple grillage model that we've created. Say no to that. So if I look down on plan, now at the moment, I'm just looking at the longitudinal lines on the grillage. If I right-hand mouse button set all as visible, you can see the transverse members as well. So it's essentially a fairly simple grillage model. The other thing that we've added to version 19 is this view cube and viewing facilities here. And it just allows me to click on the cube and I can rotate the model and look at it from different directions. But it also gives you a clear view of the direction you're viewing the model from. So if I click on the top, I'm looking down on the top of the model. If I click on the isometric here, I can see that I'm looking at the top, the front to the right, the left is to the left. So it's just an easier way of making sure you understand the visualization of your model. Now at the moment, we've basically got some general attributes in this model, and I've also pre-prepared some analyses, but I'm now going to populate these with the grillage sections and also the temperature profiles. So let's start with the grillage section. So if I now go to attributes, geometric, you can see we've got this item here for bridge deck grillage, and start with, I'm going to look at the longitudinal members, and those are going to be a girder and top slab. So here we select the girder that we want to use by clicking here, and this will take you to the section library. Now I'm going to use a user-defined section that I created, and it's for this precast eye girder that I'm looking at here. I'm going to OK that. So that's the main girder section that I want to work with. If I now go to the slab tab, I can define how I want to consider the slab. So I'm going to look at a 2 meter width of slab. It's going to be 0.25 thick. I could set an effective width if I wanted to, And if I was looking at a section that was cracked in tension, I could specify the reinforcement here. If I now go to the girder and slab tab, this is where you can specify whether you want it to be uncracked or cracked. You can specify how you want torsion to be dealt with and whether you want a warping restraint to be added to the section. Now I'm just going to call this I-beam and OK that. So there's my I-beam section. I'm also going to create a section for the deck slab. So this is just going to be a slab section on its own. Now, if you were doing a voided slab, we can also look at voided longitudinally or transverse, but we're just going to look at a solid section here. And again, this is going to be 2 meters and it's going to be 0.25 thick. And again, in this particular case, I could look at cracked or uncracked sections. I'm just going to look at uncracked in this case. And I'm just going to call this slab. And okay, that. So we've got these 2 sections. Now I want to apply these to the lines within the model. So what I'm going to do is I'm just going to copy. I'm going to go to the groups tab and I'm going to paste onto the group that I've created. So there you can see the girder and slab properties. I'm going to copy the slab and paste that onto the slab properties. Okay, so there's my basic grillage section set up. What I want to do now is create the material properties that I'm going to use for this particular analysis. So if I go to the material library, I can choose the concrete properties and I can then choose the Australian, and I'm going to go for a 50 MPa concrete property. So that's fine. So this is the material properties that I'm going to work with. And basically in here, I'm just going to call these short-term properties. And I'm going to OK that. So these appear in the tree view here. If I right-hand mouse button, edit the attributes, I can give these a different name, long-term. And essentially what I'm going to do is take the Young's modulus here and divide by 3 for the long-term case. Okay, so I've set up some properties here. And I'm going to go down to Material, Bridge Deck Grillages. And I can then start to set up how I want these short-term, long-term properties to be considered. So for the wet concrete case, no, let's do the short-term first of all. So for short-term, I'm going to select the short-term properties. And just call this short-term properties. And in this particular case, I want the stiffness for both to be taken into account. So if I hit apply, I can then change these to the long-term properties. And I'm just going to change the materials I'm working with here. And again, for the long term, this would be for things like superimposed dead load surfacing. I want the stiffness of both to be taken into account. And for the wet concrete case, I want the mass for both to be taken into account, but I don't want the stiffness of the slab to be taken into account. So when I'm pouring the wet concrete, I want the weight of the slab to be applied to the girder automatically without having to define a deactivation on the structure. Okay, so these are the properties here. So what I can do is then assign them to the analyses that I've already set up. So I'm going to select my model. I'm going to drag on the short-term properties and apply those to analysis 1 short-term. My long-term properties into analysis 2 long-term. And then the wet concrete case into analysis 3 dead load. Okay, so I've set those properties up. I'm just going to set the longitudinal beams as set as only visible, and then I'm going to solve this model. Now, because we've got 3 analyses, you'll see the 3 analyses being solved. Now, at the moment, on this particular structure, you can see that we're looking at stresses in this particular contour, and we're looking at stresses of the long-term surfacing case. But if I set active the short-term, or the dead load case, you'll see the slab stresses are no longer there because we've told the system that the stiffness of the slab doesn't exist in this case. So the mass of the slab is being applied to the girder, and the girder is taking both the mass of the girder and the mass of the slab. If I look at the long-term case, again, the slab is now activated. Now, these properties can obviously be combined together, and I get the correct build-up of stresses based on the sort of construction sequence I'm looking at. So that's the girder section properties and the way those changed. I'm now going to put a temperature profile onto this structure. So if I go to Bridge, Temperature Profiles, I'm going to do AS5100. And here I can set up the temperature profile that I want to look at. So here I'm looking at a girder beam slab structure. I can choose the criteria. So I'm going to look at a coastal temperature, no further than 200 kilometers from the coast. And I'm going to look at a soffit within 8 meters of the ground. So these design choices set up the temperature profiles you want. Now, because we're working with grillage sections here, we're only looking at the flexural case. But if I was using this on a thick beam model, I could look at the axial load case, or I could look at both. So let me just call this temp, and OK. And what we get here in the tree view is temp positive, temp negative. So I'm going to apply these to the longitudinal girder sections. So I'm just going to select all the lines in my model. I'm going to drag on the temp positive case, and I'm going to apply this to the short-term case, and I'm going to apply that as temp positive. And obviously I could apply the temp negative, but what I want to do is just run this. Okay, so if I now look at this particular case, you see the stresses that the temperature profile has been causing. But if I switch on the deform mesh and switch off the mesh, you can see that the positive temperature profile is causing a hogging effect on the deck, because essentially we're heating up the top slab, that's expanding, it's causing those temperature effects to be applied to the structure. So those are the temperature profiles, new in version 19. Now, if you don't have your design code set in the structure, I can obviously go to loading, and we have the generic facility here that I can apply my temperature profiles to. Now, it looks complicated, but the easiest way of understanding that is if you create one of the temperature profiles from one of the other codes and edit those, you can see how those temperature profiles have been set up. I can also do a visualization on this. So if I type in 1.2 meters here, you can see how that temperature profile is being applied to the structure as a nonlinear two thickness temperature profile. So essentially, even if your design code isn't there, you can create nonlinear temperature profiles very easily. Okay, so that's the grillage sections and temperature profiles. I now want to talk about RC frame design. So essentially, we're going to take a model and apply some reinforcement properties to it. And from that, we're going to go on and look at a utilization of that structure. Now, in terms of the RC frame design calculations that you get out, for every selected design location, you get a detailed summary of the various design checks that have been undertaken. The colors to the right-hand side are indicating whether it's good or bad. If green's good, If it goes to red, it's showing a very high utilization or a failure. We can also look at detailed calculations of any of the sections. We can also look at a resistance interaction surface. And those interaction surfaces can either be 2D or 3D. So you can see where you are in the capacity of the section. So this particular case, we're down here. But obviously, if I applied more axial load to my section, I would move up and basically have a higher resistance on my structure. All of the design calculations can be printed out in detailed. They can be printed out directly or stored in the LUSAS reports. So let me show you this. If I go back to Modeler, I'm just going to close that down and open up another model I've prepared in the background here. So the model that we're looking at here is one of our training examples. So if anyone's been on our standard training course in the past, this is one of the examples that you might have looked at. It's a concrete arch structure. Now, the process of using the RC designer is this. You build your model as you would build any other model. But once you then get to the point where you want to look at design, you go to the design menu, go to RC frame design, and you choose which design code you want to work with. Obviously here, I'm looking at the AS5100 code. Once you've selected your design code, you can go to your geometric sections here, and you can start to apply reinforcement to them. So if I double click on the arch section here, you'll see we've got this item here that allows you to apply reinforcement. Now this reinforcement is only going to be used for the design calculations. It isn't taken into account in the overall stiffness of the member. But if I now look at the reinforcement that we specified, if I click here, this is the reinforcement section that we're looking at here. So reinforcement for beams. If I click edit on this, I can actually look at the details of this. So here we've got a cover of 40 mil, and we've got the allowance of a link for 12 mil. If I look at the layers of reinforcement here, you can see that we've got a doubly reinforced concrete section. If I click on any of these particular items here, a bit difficult to see, but can you see some of these items have gone blue? That's indicating you're looking at a particular part of the structure. If you make a mistake and you put a reinforcement bar on top of another reinforcement bar, this will be shown on red in this section here. And obviously I can specify the bar diameters, whether I want end bars to be the same. So essentially you define your reinforcement here. You can also define additional bars if you want, but mainly working with the faces is good enough. So that's the reinforcement. Now these reinforcements can be given a name, and they can also be used in multiple sections. So if I look at the uprights here, you'll notice that we're looking at the same reinforcement section, but it's just a thinner section that we're looking at. Okay, so you define your reinforcement. You'll then go to the Attributes tab, Design, and define an RC frame design attribute. I've got one here, so if I just double click on this. Now this is where you set up the design code choices that you have within the design. And this is whether you want certain parameters to be set or not set. So here you can look at an auto factor, or you can use a user-defined factor. And you can also tell how you want creep to be dealt with in the structure. Now this design attribute is assigned to the structure. Now once you've got the reinforcement defined, your design attribute defined, I can obviously solve the model. Now at the moment, I'm looking at just a diagram, and that diagram I'm looking at is for FX in this particular model. But when you define your design attribute, you will get in the post-processing here an RC frame design item. If I set this active, in this case, what it's going to show me is contour results of the design utilizations for the particular design check that I'm doing. Now, this takes a few seconds because it's going off and working out the design calculations. One thing I should say is the GoToWebinar software that we're using is quite memory intensive, so it actually slows things down. So in real life, that would have taken about half the time that you've seen. Okay, so what we're looking at here is selective points along my model where I'm looking at the design utilizations. And here I'm looking at something called util max. So this is the worst of all the design calculations I'm doing. And the good thing is you can see here that they're all below 1 effectively. So looking through this, everything's passed. Now, if you want to look at the detailed calculations, I can, rather than setting active, show results. And this is where I see a detailed list of all the calculations that I've done. Here we've got the various design calculations. Util max is the worst of those calculations effectively. And again, the colors are indicating whether it's good or bad. If it was red, it's bad usually. And I can then go off and look at any of the detailed calculations. So here, if I look at longitudinal steel design, let's just go down to 10 here, right hand mouse button. And I can show detailed results for this row. So this is giving me detailed information on the particular calculation, including clause numbers for the particular check that's being carried out. I go back to summary. Again, just look at a different location. Now, again, this is now showing me the sort of cracked and uncracked sections. If I go to the resistance interaction surfaces, I can see a 2-dimensional or a 3-dimensional representation of that interaction surface. The black point here that I'm looking at is where we currently are in the system, but it's showing me the capacity of the section as a whole in those things. Now, as I said, these calculations can be printed out or they can be added to the LUSAS report using this button here. So that's the RC calculations to AS5100. It's basically taking your existing models and allowing you to find reinforcement within the sections, but also then doing the calculations on those sections. Now, essentially, the RC frame is an additional cost option, but we are running a promotion. It's the first time we've looked at this in Australia. So we're running a promotion of 50% off the list price, and we're looking at that until the end of September. If you're interested in that, you could go to the lusasrelease.com upgrade me page, and that would allow you to then inquire about the cost of these options, or you can inquire directly by contacting myself. Now, rather than just developing new software, we're always trying to make learning the software as easy as possible. So we've increased the number of examples we've got. Some of these are new examples, some are updated examples. Here we've got a complete list of the examples that have been changed in version 19. So we've got examples looking at the steel composite wizard. We've got a new slope stability example. So we're looking at a Phi-c reduction on that. So have a look at the examples. Even if you've used LUSAS for a long time, we're always updating the examples to include the new facilities. This is a complete list of the new facilities that have been added into version 19. Now, there's no way in a 45-minute webinar I could cover all these facilities. So if you're interested, check out the website, or when you've updated to version 19, have a look at the what's new facilities under the help system, and that will give you a detailed breakdown of all the developments that have gone into version 19. Want to know more? Obviously, you can speak to the technical support, or you could look at the LUSAS user area. We have a dedicated version 19 website that has highlights and videos of the new facilities. We also have regional and bespoke training courses. Now, in these difficult times, most of our training is now being done online, but it's something we're moving into in terms of, rather than being physical present at offices, we can provide bespoke e-learning courses or just standard e-learning courses based on standard material. So that's the event that I was looking at today. Now, I haven't actually answered any questions, but when I will leave the webinar running for, say, 10 minutes. So if you want to ask questions, please do, and I will then get back to you via email in terms of the questions you've answered. So thank you for attending today's presentation on version 19, more design, more applications, more productivity.